Welcome back to Foundations Python. My name is Dennis. We'll get started with standard data input and output. Let's get started. Our learning objectives today include creating sample programs that take in user input. We're going to manipulate that data to change output types and redirect it to different locations. We'll also identify different encoding types and transform the data to and from different encodings. All right, let's go ahead and get started. Inputs. What do you consider as standard input? Well, in Linux, we learned about standard input being anything from the keyboard or potentially anything from the user itself, whether it be from a file or directly from another standard out. Keep that in mind as we go forward. So, to create a standard input in terms of the user, we remember, the input function. Now, never mind the fact that I'm importing the sys and regular expression models. Just focus on the user input for now. Same place, enter your name. And for security purposes, I'm going to see if we're potentially putting in something malicious. So instead of my name, I put in a different payload, which is a common cross-site scripting script for JavaScript. And let's say instead of that I want to see if there is a potential issue with the website or vulnerability check. Well, I also want to create checks against that. I want to filter out what's too long or what shouldn't be in there. Like your name shouldn't have potentially apostrophes and other brackets, and at least in most cases. And typically your name is not going to be more than 50 characters long, or though it could be, maybe 75. Something reasonable. Surely that's less than 100 in most cases. And I also want to use input scrubbing, which is defanging, using the regular expressions right here. And I want to substitute anything that has meta characters, like the ones that you see right here that match to my payload. And I want you to make sure it goes into nothing. I want you to strip it all out before printing it back to me. Sounds pretty straightforward. Let's take a look. Now, as soon as I entered in my cross-site scripting dialog here, everything has been stripped out. It's now one large string, and it's as if I made my name script alert as XSS script instead. It's all been stripped out, and it's under 50 characters. Now that we know we can take user input and compare it against different things, let's try something a little bit more interesting. Let's check for the appropriate number of runtimes and run it from the command line using standard input from a file. To do so, we're going to use sysargv, the sys module library, and we're going to say, hey, check it also. If you don't have a standard data file in here during runtime with my Python file, print and exit, right? Say what my usage is, and you notice I equals it if its length of equals to 1. Now, in sysargv, it measures Python running by itself is 1 argument. You never have 0. If you have 2 arguments, you're actually saying that it's my file name main.py. The second argument is really the second argument, which is the argument of 1, argument index of 1. Remember, 0 and 1. That means that's my flat file. So that's my path to my file. Now from here, something looks familiar from our earlier lectures. I'm opening the file from the operating system, which is ironically in the same directory. And now I want to iterate over that via stream. So I want to say, hey, for my untrusted input, use the same code base, strip everything out and defang everything. Now I want to take something that is potentially a domain name and then curl. I can use the external curl command to go and reach out and try to grab the headers of those domain names. In this case, I see a bunch of output.txt domain names, and it strips it all out and says portquiz.net is one, and some other websites like 1111 is another one, stuff of that nature. So I can actually iterate over files for not just pinging stuff anymore. I can also do input validation at that and make sure I have a file name as opposed to specifying a static file name inside the program. That means I can change the standard input to whatever I want in a more convenient fashion using that script. Here's another one. Let's say I want to create a fake API. Well, sure, I'll create a mock API. I'll import my libraries using Flask. I want that API to do something on my system. So from the internet, supposedly, hopefully it's secure. I'll say if you came to /foo and you did HTTP post here, run the definition of foo, right? Our function of foo says take the request data input. And if you see the command data here in the domain, go ahead and read it back to me and turn it into a JSON key value dictionary output. That's right here. So what happens? Well, I do a post request to foo, and I get a return of that. Now, that's not a return, is it? No, it's not. What else could be happening? Well, I'm actually inserting the data. So using curl, I'm not returning this data, actually. Right? That's not the case. I'm actually using curl. I can get pin working. I'm actually using curl to ingest this data and to do something right here. The command right here, I want to ping this domain or this host. I want to ping Google. I want not my system to do it. I want your system to do this, right? Hopefully over the internet. Hopefully it's not going to be unauthenticated, but this is just a sample API. Using HTTP Postman instead of curl, I can do the same exact thing. Specify a key value pair inside a JSON format. I go ahead and activate my script, and now I'm pinging 8888, in this case, my local system, but if this API was hosted elsewhere, I'm asking someone else to ping it and give me the response back. Really cool. So some common encodings, right? Now encodings are used for the web because, again, legacy systems or other systems don't understand certain characters. Take a moment to read this table, and then let's continue forward. Okay, so you should see already that we have UTF and ASCII, which means standard English characters. Whoops. Again, sorry about that, my pen. Right? That just means UTF-8 means 8 bits, which is a byte, and ASCII, so anything in US English characters. However, if you want Unicode, which is UTF-16, down here, allows for international characters and emojis natively. You don't get that scribble if you use someone in another language that uses print, such as Japanese or particularly Chinese. You also have Basic-4, which we also saw with CyberChef. And of course, you have URL encodings, which are interesting because you can actually replace potentially bad characters that might be interpreted differently as you encode in the application. And the web browser will understand the URL encodings automatically using hexadecimal values with the percentage signs. Of course, you have pure hexadecimal value, usually for binary transportation of data. And you can base encode binary base64 using hexadecimal. So you have a double encoding in that perspective. Now, the encoding and the authentication example, we saw this in the previous section already. Let's think about what it really means if we were to actually authenticate something through the internet over an API call. I have my mobile app right here. I'm going to pass through the server, and this is my authentication server. Okay, let's pretend that's my authentication server. If I'm using a username and password, it's going to be passed through, and I have to pass this as a true before the data continues forward and returns back my request. If there's a false, my connection drops right here, and therefore my API fails. That's how authentication works in many cases beyond API keys. Keep this in mind as you develop and design systems, especially if you're doing so for cybersecurity requirements. Now, authentication comes through many different ways, and one way here is Again, what we saw earlier right here. Mobile app and all kinds of different items here. But remember, we can also have many other aspects and key features, such as integers, floats, and operations, right? The most important part in your authentication, in your input validation, which I want to put here, input validation, right? You need to make sure that a string is a string, integer is an integer, and a float is a float. And if you're using other cryptographic information or transforms, you have to understand that those should be the same strongly typed information. Let's try another one. Interactive data. I want to have input and static assignments at runtime. Sounds pretty straightforward to me. We probably already saw this all together. Again, input function, instead of static functions. Remember, it always is interpreted as a string, right? Very important information right there. And if you try to make an operation against it mathematically, it's going to error out. Again, read your error messages. Cannot concatenate an integer. Again, turn it into a string first. Now let's take a look at outputs. Standard out is anything to the console. Right? This is pretty straightforward, just like in Linux. So using the print function, that provides me standard out. But how can I redirect it somewhere else? Good question. The file system's one, right? Instead of just opening files, we can actually write to files. So let's say we have static information right here. Whoops, that's not a very good arrow. And I don't want that. The file system. Right? We have interesting different things together. And I have a file handle. So I can open a new file and instead of reading it, I can write. And I can write my characters to it using the .write method. I'll then close it. Instead of just writing a brand new file and cluttering it, I can actually append a file and do the exact same thing. And notice my output now, instead of to the console, is redirected to the file, and I can cat it from the outside in. Take a moment to pause and think about what just happened here and how you can redirect standard out. Okay, welcome back. Went ahead and moved on to the slides. Another way to redirect standard in is to output it into a database. So other than a file, you can actually create it into databases. There are two types of databases, SQL and NoSQL type databases. SQL type, which means structured query language, includes Microsoft SQL, MySQL, Postgres, Arial, and Oracle. And some NoSQL types also include Amazon DynamoDB, Mongo, GraphQL, and Cassandra. Notice the difference between the two. And let's get this into our pen here. Right, a NoSQL query was do it based on key value pairs. Remember the key value pairs as a dictionary inside Python? There you go. Now, SQL queries, again, are transactional and relational focused. So it says it's like who, from, where, and why, essentially. Now, SQL-based queries, remember, ask atomicity, consistency, isolation, and durability. Basically, strongly consistent transactions. For NoSQL applications, and if you have flexible data schema requirements, the typical use cases there are for NoSQL like DynamoDB, and for eventually consistent writes. From a conceptual standpoint, and we'll visit more about this when we get to further development, SQL again means relational-based transactions. Think of transactions, relations, and strongly consistent. OLAP is another terminology used if you have multidimensional data, such as SQL. You'll need to have relations across all of them. For very simple type data, or ones that you need a graph, NoSQL is probably the better option. Document objects to refer from a metadata, column-based key value pairs and graphs, key value pairs being dictionaries inside Python, or where you want to utilize some of these use cases and where you want to have them into certain types of databases. Here's a DynamoDB example. I'm going to go ahead and write this program that goes ahead and says, I'm going to import Boto3, which is the SDK for Python for AWS. I'll name a resource, which means a table is already created. And I'm just going to add an item in there. I'm going to put the key value pair or attributes in here, hello world. Hello being my key, hello world being my key, and foo and bar being another column and value associated with that attribute. Notice that I didn't have to define my schema ahead of time. I can just keep adding on to it inside my table at the column record. Then I can query this and provide the information back to me based on the items I had placed in there. Let's take a break and do a quick demo, and we'll see you back shortly. Hi, and welcome back. I hope you had a great break. Let's go ahead and revisit the idea that we're going to write to a database. For now, we're going to use Amazon DynamoDB, which is a NoSQL serverless database inside the AWS. I'm inside my Cloud9 IDE environment, which has the permissions all ready to go ahead and write to DynamoDB or really any service I'm looking for. How do I know that? Well, I'll go into Cloud9. I can always go into my environment right here. But more importantly, I can go to IAM. Again, I want to stay in US East 2, especially in your labs. Keep that in mind. I'll go into my roles. And then I'll use Cloud9, the access role, and the service role for it. Service link role right here. And let's look at my permissions. I have a service role policy. And I have access to many, many different items here. Okay. So using my IAM permissions passed to that, I have these permissions right here for EC2 and many different things. One of the most important items here is that I am inside my item here. So we can look at AWS STS question mark. We'll see AWS STS get caller identity. And as you can see here, I am logged in as the user, DW Chow, assuming my administrative role and privileges right here. And this is my ARN and my user ID. And because I can use my get session token, I can actually grab the token, which is my access key, secret access key, and the temporary token information, as you recall from the AWS Foundations course. But never mind that. That's how Cloud9 is able from my EC2 instance inside Cloud9 to access all the other items because of my role assigned to Dennis Chow. So we go to my role of Dennis Chow, and my IAM user, DW Chow. We'll see my permissions that I am a full-blown administrator, which has everything under the sun. Now, in the real life, you'll use limited functions and limit roles, but I just wanted to show you how your Cloud9 will interact with other services for the first time. Now, standard out is no fun necessarily. If you go back to my, let's go to create a quick demonstration here. You know, standard out is pretty much anything that you get from here, right? This is standard out. You know, that's standard out. We could write to a file. More importantly, let's look at enterprise where you're going to write to a database of some type. But here's our sample code here. And notice if you're doing this not inside a Cloud9 environment, you're going to be using your access keys instead, using the AWS configure. To create an object and a handle, we'll say we specify the DynamoDB resource, and we have a table name of demo. Okay, and that's assuming that we already have that table created. We're not creating it right now. I want to put an item in here that has the following attributes, which is message and hello world, foo and bar accordingly. All right, so what is our key here? Our key would be message in this case. Let's create a new table in US East 2. What did I call it? I called it demo right here. And then our key needs to be hello world in my case. So I'll say message. I'll say my partition key is message. Sort key is optional. Default settings. Why not? Create table. And now it's currently active. We go to the table. We should see my settings here, and we can view items, which is currently none. And that actually makes the table scan. I want to go ahead and set this to an easier view. Okay. Knowing that we have what we have here, and we can actually get our response down here, which is a query of the message key message and hello world. We can run, for example, right here. No module found below 3. And that's because, even though I created it, I did not activate the virtual environment. So I'll go in here, I'll ls, and notice I have my libraries right here. I went ahead and created the virtual environment, so I'll need to go ahead and activate it. Source dot activate. And then I'll do Python db. And now we put something in there, and we got the results back with a successful 200 OK and our request ID accordingly. Our results back is now hello world with foobar as additional attributes. Run the scan again, and now it's finally populated. You see the attribute name includes our partition key, additional attributes, and bar. I can keep running it, and it will keep providing me the same information as instructed. So that's our demonstration for now. You'll come into the lab and you'll be doing some more items with DynamoDB. Hope you have a great time. Thanks for watching. We'll see you in the next lecture.